Hi team. So from this video we are going to learn some of the important aspect of this IT industry. This is gonna be the fundamental as well as in-depth series which I am be covering in this playlist. Here you are gonna learn few critical aspect that is necessary when you are developing some software, some application. So from this video, we are going to mainly focus on the system design. First, we would cover the basic and fundamental concept which are required for system design. We would start with low level design and after it we will move to high level design HLD. So why do we need system design? This is our main question, like what is the need of that, what is the requirement of that. So for this, we face several problems when we are developing high scale application, such as we need to maintain it, we need to scale it, we need to availability, our application or our software which is that should be available for all the time. Like for example Google, this is available all the time. It doesn't matter at a current instant how many users are on it. This application is able to scale that much and provide output to each one. So this is like and so this kind of gain can happen when you are mastering system design. System design is basically a concept which focuses on how your application should be and how your application should perform, like from building to high level, how you should monitor it and how you actually technically know the terms. That's it. So we would start with system design. We would can start from the basic fundamentals, like we know as a solid principle. Solid principle is the a person who has made some rule that we should follow when we are developing some application, some sort of software, to avoid and so there would be problems about scalability, maintainability. So that can be easy to handle at the time of integration, adding new feature to our existing application. In this cases, we would require this concept to be used so that our application would able to easily integrate, easily scale, easily can scale at a larger scale. So for that, we have several principles so that we should follow. The main reason, I'll just giving you a three reason that with using this application like this solid principle, these problems can be avoided. I'm not I can't guarantee you that it will be not come, but yeah, at maximum level this problem would be skipped or neglected, right, when you are using this solid principle. The first reason that most obvious is the maintainability. So if you are working in real world application, the code base is huge. There were thousands of files, and thousands of files would have thousands of lines of code. So and in that code, if you want to add some feature, you want to integrate some feature or some a new thing, if you want to add, so that would be hard. If you have application that may break your entire application, or so that will affect so many things. So to avoid that, we have to avoid this type of problem, we can start with and have some sort of the critical things so we can handle it. Second one is the reliability, like using solar principle. This uh, suppose you're working for some company and you are like now transferred to some other project that's you are new to that, to like get that project, like how like time on this. And so like ideally we would want to learn this in depth, like how it should be. Then second is the Liskov substitution principle. For example, like I'll just give you a definition first. So this principle says if you have a child and parent, and if your client is using parent, so your child should can able to like replace the parent. Means suppose there is like inheritance kind of thing, and if you are inheriting some class or extending some class, then your child class should broaden the functionality, not narrow it down. If it is like have at least the minimum feature of what parents have plus additional feature, then we can say that this principle is being followed. Then second one is the interface segregation principle. For example, you have like a certain task. For example, uh, you have created some hotel management thing. So there would be like one person who would be waiter, one person who would be cook, one person who can manage the billings and all those things like cashier. So you should not like read all this function in a single class. For that, what you can do, you can have like multiple interfaces. This we got as like interface segregation. So uh, this principle is basically says if you want, if particular class requires some functionality only, so you should implement that only. So for that, like there would be like separate interfaces, so those will get followed. Then the last principle is the dependency inversion principle. It says you should not have a tight coupling between your code. It always been loose coupling. For example, you have mouse can have like two types, wired one and wireless one. So while creating an object, you should not create an object of like wired or wireless. In future, like if you just think like I don't need a wired mouse, I need like wireless thing, so at that time you should able to like replace it. And if you have like tight coupling, then you need to like, so that would be hectic for it, so that would be headache. So these were the like five basics for it principle what we have. And I guess I have explained a bit. I just gave you a broader idea like how it should be. But in upcoming videos we are gonna like learn this in depth with obviously a code in it. So I guess this is it for this video, and we would be